Many European rivers contain chemical cocktails that may be harmful for algae and aquatic animals. Indeed, concentrations of selected chemicals are monitored in the European Union. However, are they the ones to blame? And is it necessary and possible to monitor all chemicals? After all, about 140 million chemicals are known, about 100,000 we have in daily use. In addition, we have numerous unintended byproducts, environmental transformation products and many more. A large fraction of them can be found sooner or later in our rivers and lakes. Pesticides, pharmaceutical components of detergents and cosmetics, effects on the ecosystem to be explored. Within the frame of the European project Solutions, scientists develop methods and tools to assess the risks posed by chemical mixtures in European rivers and to mitigate toxic contamination. The project is coordinated by Dr. Werner Brack from Helmholtz Center for Environmental Research, in short UFZ, in Leipzig, Germany. What is Solutions?
Well, Solution is the acronym for a large 5-year EU project with the full title Solutions for Present and Future Emerging Pollutants in Water and Land Resources Management. 39 partners from all over Europe are working together, also partners from China, Australia, Brazil. All of them are working together in order to find solutions for the management, assessment and monitoring of the complex mixture of environmental pollutants we find in our rivers and that may pose a risk to the ecosystems as well as to human health.
Why did we need solutions? Isn't the European Water Framework Directive already a unique instrument for the management of a good quality status of our rivers and lakes?
Well, the Water Framework Directive is indeed unique. It has a very ambitious goal, the very ambitious goal to reach a good ecological and chemical status in all rivers in Europe. However, the approaches that are used to reach these goals, they fall short of the ambitions. And that holds specifically for the chemical status, for example. The chemical status is based on 45 so-called priority pollutants. So pollutants we identified as very problematic and they should be removed. They should be removed from our rivers. And well, this actually was quite successful. So they actually were removed from the market, most of them at least. The concentrations are declining. However, the problem is that these chemicals have been replaced by many other chemicals which have similar properties, similar risks, and which are not considered at all in the chemical status. Well, if we have a look on the 100,000 chemicals we have in daily use and which arrive in the environment finally, we also see how short this approach falls. But on the other hand, we also have problems with the priority pollutants we have. Some of them, such as mercury, for example, and polyaromatic hydrocarbons, they exceed environmental quality standards all over Europe. So we have a bad chemical status all over Europe without an idea how to manage that, what to do about that. So what we need is a more holistic chemical status on the one hand, considering the whole mixture, and a chemical status that is really discriminating between more and less polluted, more and less problematic sites. And this is more or less the task to develop this is the task of Solutions.
Let's look back to 5 years of Solutions. What were the ambitions of the project partners?
Well, the major goal of Solutions was to do the big step from a purely status-related monitoring and assessment of environmental pollution towards a solution-oriented one. And this means, of course, first of all, a better and other monitoring that is really able to discriminate between more problematic mixtures and less problematic mixtures. There is second, of course, the question, what are the chemicals behind these problematic mixtures? Who is driving the risk at the end? Then we wanted to link the chemical status, chemical pollution, with the ecological status, which is the final goal of the Water Framework Directive, so to reach a good ecological status all over Europe. And we wanted to do the step from pure monitoring towards also using predictive models, because we had the feeling that they could help us in improving monitoring. And of course, abatement and mitigation measures. So we wanted to have a look on what are mitigation measures that really could help to reduce the problem. Of course, we wanted to also demonstrate that the new tools we were developing, that they are working and that they really support a better management. And we wanted to do that in big case studies, such as the Danube River and the Rhine River, for example. And of course, we really wanted to have that not as an academic event, but as something that is really, produces solutions for our stakeholders, for practitioners. So from the very beginning, we were strongly collaborating with decision makers and with a lot of different policies from national and European agencies and so on.
How did you do that?
Well, we had the great opportunity to join from the very beginning, in the first month already, one of the biggest river expeditions that ever has been done in the world. The joint Danube Survey 3, starting from Germany, going down to the Delta with 2 big research ships in 6 weeks. We collected thousands of samples, water samples, invertebrates, biofilms, fish and so on. And of course a lot of laboratory work involving many different scientists from different institutes and countries was following. And then we compared what we found there with the ecological investigations that have been done in parallel and with our predictions we got from modeling. So I think that was quite interesting and quite successful, but we also had other opportunities to really contribute with our research to ongoing important developments. One of these issues is, for example, the implementation of the decision in Switzerland to upgrade wastewater treatment. At least all the big wastewater treatment plants should be upgraded with quaternary treatment. And we had the nice opportunity to actually monitor the success of this approach. So directly compare the ecological impact before and after this implementation. So a lot of field work, a lot of laboratory work, but also a lot of people were just, let's say, sitting at the computer, evaluating a lot of data and doing new models for prediction of the distribution of chemicals in the whole European water network.
What did you achieve?
Well, most of the goals we had in solutions we actually achieved. And one thing I would want to stress here is monitoring, having a better monitoring. And what we wanted to do is to complement concentration-based monitoring with monitoring based on effects on organisms. No? Because that's the possibility to really monitor the complex mixtures and their effects. And in order to do that, we investigated a lot of existing bioassays for their ability to detect chemicals with different modes of action, not only individually, because that's what is typically done with these assays, but also in complex mixtures and in environmental samples. And from these results, we compiled a biotest battery and suggested a biotest battery that is now discussed on a European level, including organismic tests based on algae, daphnia, fish embryos and so on, in order to check for acute toxicity to these organisms, but also very specific cellular assays that are helpful to identify risks and effects on to identify long-term effects, such as effects on reproduction of organisms, for example. But of course, if you want to judge the results of such effect-based monitoring, you also need effect-based trigger values. What is good, what is bad. And also there we could help and develop effect-based trigger values for, or suggest effect-based trigger values for a lot of different toxicological endpoints. But also with modeling we were quite successful. We compiled a full model train from emission via the distribution of the chemicals, the transport of the chemicals, down to the to risk assessment, and compared the results with what we found with our monitoring in the case studies. And the agreement was quite good in many cases. Also, of course, there are site-specific uncertainties and deviation. That's no doubt. And many of the uncertainties are just coming from the non-availability of data for emission, for production. So everything needed to be predicted. But what the modeling was particularly helpful for is to identify those chemicals that are very probably not of risk for our ecosystems and for human health, because the concentrations were definitely too low. We also had a look on mitigation measures, on abatement options, and these mitigation measures, of course, start with the chemicals themselves. So the question of producing less toxic and better biodegradable chemicals. That goes on with the use and the production of the chemicals. And finally, of course, we have actually end-of-pipe solutions such as treatment of wastewater, treatment of drinking water. And here, for example, we had this example from Switzerland where we could show that the upgrade of the wastewater treatment plants actually leads to a big improvement of water quality downstream in the Swiss rivers.
Where do you see further need for action?
Well, most of the approaches, most of the tools we developed, we really brought to a status where they can be used in monitoring. And I think that needs to be done now. And it needs to be tested in routine monitoring now. And there are already, first new case studies in collaboration with our stakeholders in planning. And focusing on agricultural streams, for example, focusing on wastewater treatment plants all over Europe, and so on. So the practical implementation, the test on a bigger scale. There is one other thing that came up in solutions, which was not directly planned there. That chemical and toxicological fingerprints related to specific sources are a very, very helpful tool to trace back what we find in our rivers to specific sources and also to management measures, for example. From fingerprints to footprints, I think that is also a tool that is, quite often used in environmental science for products, for measures, even for whole regions, to check for the ecological footprint of these activities or products. And we translated this approach in solutions, we translated this approach to the chemical footprint. And what is it? It's basically the question, do we have enough water to dilute the chemicals we are emitting to concentrations which are safe for the environment and safe for humans? Of course, we cannot increase the water amount, so if it's not safe, we have to reduce the chemical footprint.
Just to the point, how would you summarize the core message of solutions?
Well, for effective and cost-efficient management of water quality, we need solution-oriented monitoring and assessment. And I think solutions provide the tools to do so, such as effect-based monitoring, predictive models, and so on. And we even demonstrate that they are working in these large European case studies. So now let's implement them.
Was solutions research in the ivory tower, or could you make a difference also politically?
Well, already from a scientific point of view, solutions was quite successful with around 100 international publications, the same number of presentations on international conferences, a lot of workshops with stakeholders, with scientists, and so on. So the international awareness of the project and of its results is quite high. and not only in Europe, but even beyond. So we were invited to Japan, to Taiwan, to China, to Brazil, in order to present the results, because solutions is a kind of example also for other countries all over the world. Well, due to the fact that we actually collaborated from the very beginning very intensively with European and national decision makers, with agencies, with the water industry and so on, we actually were able to feed in our research and our results into political processes. And well, just to give you one example, one of the important tools we developed is effect-based monitoring. And this effect-based monitoring that was not included in Water Framework Directive before at all, but we brought it into the process, and even the water directors, so the major decision-making board on a European scale, they gave the go-ahead for the development of these effect-based monitoring tools. Working group under the umbrella of the European Commission was implemented to develop the guidance, to develop guidelines for the use of these effect-based monitoring tools. We are part of that, of this working group, of course. So all these things were really brought forward by solutions. On the other hand, we also feed it directly into, well, river basin management plans, for example, under the Water Framework Directive of the Danube River, for example. And we developed tools that help practitioners to directly and to optimally implement and use the tools and the approaches we developed in solutions, such as a user-friendly decision support system, for example.
Which objectives do you have for your final conference?
Well, the final conference gives us the opportunity to present the results we got in solutions in an integrated and condensed way to the scientific community, but particularly to our stakeholders. And well, we will have a lot of very interesting presentations from solutions, but also from our stakeholders and the discussion among them. So the focus is very much not only on pure science, but on application and implementation of our tools. However, I think it's also plurality of our presentation that makes this conference unique and very interesting. So we have a session, for example, where young scientists are presenting their outstanding work. We have also a podiums discussion where we are discussing what kind of research we need in future, particularly in front of the background of the different needs we have. So high water quality and enough water of high water quality, the protection of biodiversity, but also, well, the increasing needs of food production, of energy production, and so on. So this whole context will be discussed in the conference.
What will be after solutions? Do we really need European environmental science, or can we make it also on a national level?
Well, the challenge of good water quality and of sustainable chemistry is, of course, a global challenge, and it needs to be addressed at least on a continental scale. And if you have a look on the big European rivers, for example, all of these, or almost all of these big European rivers, are international rivers flowing through different countries. The River Danube, for example, is passing through 10 different countries. So it's a real European problem, and the pollution does not care at all about national borders, for example. And also the regulation, of course, is an international one or a European one. So the Water Framework Directive is the regulation for water management in Europe. It's not a national one, it's a European one. And last but not least, the expertise we need is an international one. So the results we achieved in solutions would be not achievable only on a national level. No, we involved the leading experts in Europe, the leading experts in 16 different countries, in order to bring together this expertise and solve what we needed to solve. And so I think this kind of applied European research is really a success story, and I think we should continue with that.